Let's start with a non-example of set equality. Assume you have two sets A and B which each contain a number of elements. As you can see, these two sets are not equal because B is a subset of A, but A is not a subset of B. All the elements of the set A which don't stop at 10 are not in set B, which does terminate. The difference between these two sets is that A is a set of all even numbers, whereas B is just a set of 4 numbers. So here's another example. These two sets are equivalent because all natural numbers are positive integers and all positive integers are natural numbers. Since the two sets are subsets of each other, they are equivalent to each other. A equals B. This example is a little different because we have duplicate elements as well as a different order. Still, A equals B. Here are a couple of side notes which apply in particular to the third example. There are 4 operations that can be performed on sets, and they are union, intersection, complement, and difference. First, to do a union of two sets, you include all the elements in both original sets. So if we perform the union of these two sets, the result would be a set containing the elements 2, 3, 4, 7, 8, 9, and 10. The intersection would contain only the elements that both sets have in common, so that would be only 4, 9, and 10. To solve problems including complement, you'll be given a set U that contains a number of elements and one or more sets. The complement is kind of like the inverse of the set. So if we find the complement of set D, we're finding everything outside of D. In other words, we're finding everything in set U that is not in D, which is similar to the difference of U and D. In difference, you find all the elements that are in the first set that are not in the second set. if you're given these two sets and told to find the complement of set D, you're basically just canceling out all the common elements and finding all of those leftover ones in U that are not in D. To create a Venn diagram depicting sets A and B under an operation, draw two circles and label them A and B. Now choose an operation to perform on the sets, for example, intersection. Since intersection is all the elements that both sets share, the intersection of two sets would be only the section in which they overlap, and that would be the middle region. That's the intersection. For a simple problem like this, you'll only need one drawing, but for more complex ones, you may need to make a rough draft as well. Now try the intersection of A's complement with B's complement. For a problem involving complement, you'll also need to draw a set U which can be represented as a rectangle, titled U. All other sets will be drawn inside of U because everything belongs to the universal set. For this problem, you may want to use a rough draft first. After labeling A, U, and B, you need to find the complement of A first, so shade in everything outside of A. Now look at set B. I'll use a different color to shade in everything outside of B. Now, since we're finding the intersection of the complements, we need to find the parts where both colors are present. So now I'll make a cleaner final draft with only one color that depicts the entire thing.